Hey class, welcome back to our last mini lesson on Unit S, Simple Linear Regression. We're going to look on pages S23 and S24. However, I do want to remind you that on page S25, there's additional problems at the back of this unit, and the solutions are on page S26, 27, and 28. So please, please, please remember to do those afterwards for homework. And the answers are there. We're just going to concentrate on 2 pages here and really just concentrate on one, which is S24. And on page S23, we have questions that refer to page 24. So we're looking at how to read Excel output for regression. And the problem that we're going to be looking at is the ages and push-ups example. So this guy right here, age and push-ups on that. I want to make just a couple of changes on this page here. Down in C, we're going to add in here and the confidence intervals. So and the confidence intervals. And then the other thing here is on D, it says what's the adjusted R squared? We're actually going to cover that in the next unit, which is unit M. It's much better right there, so we won't actually address that particular question there. So this is referring to the next page, the output here. Instead of going back and forth, what I'm going to do is just simply read out the question from page S23, which says, go and find this value on page S24, and then we'll label it as such. I also wanted to show you the reference pages here, and this is where we did all the different kinds of calculations for the age push-ups example. So this output then is for the age push-ups example. Push-ups, okay? All right, let's take a look at what we've got here then. You know what, that's terribly written. Let's do that again. So age push-ups. Still got a little messy at the end there. Okay, question 12a says, find the B0 and the B1 values from the sample regression line. So where do you find those? They're right here. These guys right here. So this is the BI column. And so this is the B0. So that's our intercept. And this is our slope, the B1 value. And so that's where we get our regression line. Y hat is equal to 32.862 minus 0.265 times x, where x is age and y hat is push-ups hat. So that was 12a. Now 12b says find the SB0, SB1, and the T star values. So that's these guys. Let me change colors here. So that's these guys right here. So this is 12b. So these are the SBI values, and these are the T star values. So this is SB naught, 4.793, and this is SB1, 0.103. Now, for each line, if you took the 32.862 and divided it by 4.793, then you would get the T star value of 6.857. And we looked at that, I think that was on page S13, is where we did the hypothesis test. And then we did the same then for the slope, minus 0.265 divided by 0.103, and that gave us a T star of minus 2.571. So that's 12b. 12c says the p-values for the T-stars, for the t-tests, and also the confidence intervals. We'll take a look at that as well. So we're going to take a look at these last columns here. So here's the p-values right here. And remember that this 6.857 was compared to a critical value of plus or minus 2.228. Now that's not shown here on the output, but that's what we would compare it to. And we get a p-value of pretty close to 0. So it's way out in the tail. And if you look this up on a t-table, you would get 0. Now, this is always calculate these as a two-sided test, and we'll talk about that when we get into multiple regression, why they're always two-sided. But for now, all you need to know is that these p-values then assume a two-sided test, that the slope b beta 1 is equal to 0 against the alternative that it's not equal to 0, and the same for the intercept. All right? So those are the p-values, and then here's a confidence interval. So we calculated these guys by hand as well. Lower bound and the upper bound for the confidence interval for the intercept, beta naught, and then the same for the slope here for beta 1, which is the slope. So that was, what was that? That was 12C. All right, let's change colors here, and we're going to go to, where's the r squared value? The r squared value is right here. So that's 39.8%, and so that's 12D. And that actually ties in really nicely to the Anova table, which is right here. Right there, okay. So the Anova table, and that's 12E. So 12E, let's take a look at all the values there. So it says, where's the SST value? It's right here. So here's the SST of 854.250, right? SS total. Then we've got SSR up here, SS regression, 339.92. And then this is SSE, 514.330. Remember, another name for residual is error. Residual, what's left over, error, what's left over. Here's your degrees of freedom. This is P. P is equal to 1 x variable in a simple linear regression, n minus P minus 1, and n minus 1 for your SST, which we don't use actually in the formula for F star. Now, remember, if you took the 854.25 and divided it by n minus 1, you would get the variance of all of the y values. You'd get the S squared of the y's, the total variance. Anyways, getting back to the F test here, if you took a look at this value here, 39.992, that's the denominator of F star, which is SSR divided by its degrees of freedom of 1, P. And then this is the denominator, and that's 514.330 divided by 10, n minus P minus 1. So you get the denominator. And then finally, if you took the ratio of those two, you would get this guy, which is the F star value. So it's kind of hard to see that up there. That's the F star value of 6.609. The P value is the significance F. And so we didn't calculate that by hand, but the computer does that for you. It's exactly the same p-value as we have down here. So down here we've got the p-value saying the x is significant at explaining y. Remember, we would compare these p-values to alpha, and both of them are less than an alpha of 5%. And so they're both significant, same up here. So this is less than an alpha of 5%, so we would end up rejecting HO. All right, the last question on this, I'm just going to go up here so you can see it. It says, number 13, just a sec, let's go down here and say, oh yeah, I got that labeled 12E. Good. Okay, consider the table of residuals and the residual plots. Another name for residual is error, the same E that we were introduced to earlier. Each residual is the difference between the actual y value and the y hat value. Standardized residuals are calculated by dividing by the SE value. A standardized residual less than -2 or greater than +2 generally indicates an outlier. Find the two outliers for this example. I want to show you actually the plot here that we did way back on page S6. So that was on page 154 up here, right there. So this is when we were first introduced to the push-ups example, age push-ups example. Actually, we were first introduced to it on page C7 in Unit C. But here's where we plotted this thing out on page S6, right, page 154. And here's the two guys that I want us to focus on, this guy and this guy. If you take a look at the residuals, remember that's the distance from the x value to the regression line. They're really high. You can see that those are outliers. Let's take a look at where they appear then in terms of our list of residuals down here. So I'm going to go back down here to page 171 here. And I've got the residual output here, down here at the bottom. Now, what you need to do is to go into the lab folder for instructional videos, and it's on the YouTube site, and take a look then at the video that talks about eliminating outliers or dealing with outliers in a simple linear regression using Excel. And it'll tell you how to get this output here, how to get this whole output. But specifically in that particular one, it's talking about how to get these residuals. Okay? Now, let's take a look at what that paragraph up there was talking about and how we read this here. So the predicted y values here then are these guys, and they're your y bar values. Let me show you where that comes from. If you take a look, and we'd have to go back to page S6 for this, but if you take a look at the very first observation, what you're going to have here is you're going to have push-ups of 34 and an age of 19. So that's the first person that we had in the list, and you can go back to that page and check that if you want. But if we stuck that into the formula that goes like this, y hat is equal to 32.862. Remember, those are our coefficients up here. 32.862 minus 0.265 times 19. So there's the 19. We would get 27.825, which is this guy right here. Now, the actual y value is this guy right here. So if we went 34 minus 27.825, we would get the residual of 6.175, or that's the list of E's, the errors, residuals. Now, if we took that guy and divided it by the SE value up here, and I think that was one guy actually I was supposed to point out in 12E, so sorry about that. Here's your SE value, or sometimes we just call that S. And that's the standard deviation of all the error terms. If you took this and divided that by that, you get a number which is pretty close to this. Actually, Excel uses a slightly different formula. There's an adjustment here that we're not going to look at, but you're going to get something very close to it. So what we do then is we take a look at these standardized residuals here, and we find out, is there any of them which are really out there? If you took a look at your usual confidence interval, remember we tend to talk about 95% confidence intervals, and if we're talking about Z scores, then it's plus or minus 1.96 is the numbers that we would use for 95% confidence interval. So basically plus or minus 2. So what statisticians do is they look at the error terms, which are normally distributed, and any of them which are outside plus or minus 2 are outliers. This guy is an outlier. This guy, oops, that sometimes disappears on me. There we go. So this guy here is an outlier. When we get rid of him, actually, the regression line will redraw itself, and this guy will become an outlier. And take a look at that particular little video there that I made for the lab. on eliminating outliers, and it'll show you how to get rid of those. And what you find actually is that the R-squared value really jumps up high. So it goes from about 40% to 66% to about 95%, I think it is, just by eliminating two values. So that's it. That's how you read it. I should just point out here's your residuals right there. This is just a plot of the errors, just a scatter plot, and there they are right there. So that's also a good way to find them there. But I generally just look at these numbers right here. So that's it. That's the end of Unit S. And remember once again to do those problems at the end, starting on page S25, and then I think you'll have a good handle on Unit S. So I'm going to end the lesson now. Thanks for listening.